Welcome back to NodeNotes. In today's video, we are going to learn about Chinese Postman Algorithm, one of the most useful graph algorithms used in real-world routing problems. By the end of this video, you will understand what the Chinese Postman Algorithm is, how it works, why Eulerian circuits are important, and how we can modify graphs to solve routing problems. Let's begin with a simple situation. Imagine you are a mail carrier delivering letters throughout a town. Your job isn't to visit just one house. You must travel along every street because every street has houses that need mail. Now think about this question. How can you complete your route while walking the shortest possible distance? You don't want to waste your time by walking the same road over and over again. This is exactly the problem that the Chinese Postman algorithm solves. Instead of finding the shortest path between two places, it finds the shortest route that covers every road at least once. So, what exactly is the Chinese Postman algorithm? It is the graph algorithm that finds the shortest closed route that visits every edge in a graph at least once. Notice the phrase every edge. In graph theory, an edge represents a road. The algorithm has three main goals: traverse every edge, minimize repeated edges, and return to the starting point. This algorithm was introduced in 1962 by Chinese mathematician Mei Kuo-kwan, which is why it is called the Chinese Postman algorithm. It works with both weighted graphs where roads have distances and unweighted graphs. This algorithm isn't just a classroom concept. It has many practical applications. For example, postal delivery services use it to plan efficient routes. Garbage collection trucks need to travel every street. Snowplows clear every road after heavy snowfalls. Road inspection vehicles checks every road for damage. Police patrols often cover all streets in a neighborhood. Even utility companies use similar routing methods when inspecting pipelines or electrical networks. Whenever every road needs to be visited, these algorithms become useful. Before learning the algorithm, let's quickly review some graph technology. A vertex or node represent a location or an intersection. An edge represents a road connecting two locations. A weight represents the distance or the cost of traveling that road. In this example graph, each circle is a location and each connection line is a road. Understanding these basic graph components makes the Chinese Postman algorithm much easier to understand. The Chinese Postman algorithm is based on an important graph concept called an Eulerian circuit. An Eulerian circuit is a path that visits every edge exactly once and starts and ends at the same vertex. For a graph to have an Eulerian circuit, every vertex must have an even degree. The degree of a vertex simply means the number of edges connected to it. Why does every degree needs to be even? Because every time you enter a vertex, you also need another edge to leave it. If every vertex has an even number of connections, you can always continue your journey until you return to where you started. Now let's look at something slightly different. Eulerian trail. An Eulerian trail also visits every edge exactly once. However, it does not return to the starting point. Instead, it starts and ends at different vertices. For this to happen, the graph must have exactly two vertices with odd degrees. Those two odd degree vertices become the starting and ending point of the trail. This distinction is very important because the Chinese Postman algorithm usually aims to create an Eulerian circuit. Why do we need the Chinese Postman algorithm? So here's the problem. Most railroads networks are not Eulerian. Some intersections have odd number of connecting roads. Because of this, we cannot travel every road exactly once. The only solution is to repeat certain roads. But which road should we repeat? The Chinese Postman algorithm answers this question by finding the smallest amount of extra travel needed. Instead of randomly repeating roads, it chooses the shortest path to duplicate, making the overall route as efficient as possible. Let's go through the complete algorithm step by step. Step 1. Check whether the graph is already Eulerian. If every vertex have an even degree, you are done. Step 2. Find every odd degree vertex. Step 3. Pair odd vertices together. Step 4. Find the shortest path between each pair. Step 5. Duplicate this shortest path. After duplicating them, every vertex now has an even degree. Finally, find an Eulerian circuit on the modified graph. That circuit becomes the shortest possible route that covers every road. Let's work through a simple example. Here, we have 4 vertices A, B, C and D. Let's calculate their degree. Vertex A has degree 2. Vertex B has degree 3. Vertex C has degree 2 and vertex D has a degree 1. Notice that the B and D have odd degrees. Since the graph have odd degree vertices, it is not Eulerian. We need to modify it. The next step is to connect the odd degree vertices. In the example, the shortest path is between B and D. Instead of creating a brand new road, we simply imagine traveling that road twice. This duplicates the edge. Now let's check the degrees again. B changes from 3 to 4 and D changes from 1 to 2. Now every vertex has an even degree. Our graph has successfully become Eulerian. Now that every vertex has an even degree, we can find an Eulerian circuit. One possible route is A to B, B to D, D back to B, B to C, and finally C back to A. Notice that one edge was repeated. Even though we repeated a road, every edge has now been covered, and the route returns to the starting point, which is A. This is exactly what the Chinese Postman algorithm is designed to achieve. Now, let's briefly discuss efficiency. The running times depend on several operations. Finally, odd degree vertices is relatively fast. Finding the shortest path between odd vertices requires algorithms such as Dijkstra's or Floyd-Warshall. Pairing odd vertices is the most computationally expensive part. Finally, constructing the Eulerian circuit is comparatively efficient. Overall, the complexity is commonly around O V cube, depending on the implementation and shortest path algorithm used. For small and medium-sized graphs, this algorithm performs really well. Like every algorithms, the Chinese Postman algorithm has both strengths and limitations. Advantages include it guarantees that every road is covered and it minimizes the unnecessary travel. It has many practical real-world applications and it improves efficiency in transportation and logistics. However, there are some limitations. Large graphs requires more computations, and finding the best pairing of odd vertices becomes increasingly complex as the graph grows. Even so, it remains one of the most useful routing algorithms in graph theory. Let's quickly summarize what we learned today. We learned what the Chinese Postman algorithm is and why it is useful. We understood the differences between an Eulerian circuit and an Eulerian trail. We learned why odd-degree vertices prevent a graph from being Eulerian. We explored how the algorithm modifies a graph by duplicating the shortest path between odd vertices. Finally, we saw a complete example and discussed its operations and time complexity. I hope this video helped you understand the Chinese Postman algorithm in a simple and practical way. If you enjoyed this lesson, don't forget to like the video, share it with your friends, and subscribe to NodeNotes for more easy to understand tutorials on data structures and algorithms. Thank you so much for watching. Bye.